You're muted, Vlad.
Really? That's awful. I've already done like several minutes of my presentation.
Oh no.
Okay, you saw everyone that I have deleted modules folder, right? Makes sense. There is no more. Let me repeat it once again. Today, we make a decision not to use modules anymore. We will immediately delete them right now, and the folder as well. We will never ever use, at least in these classes, we will never ever use our own modules again. What we'll use instead is a centralized, publicly available registry of open source module written and maintained by Terraform enthusiasts across the world. It's like a candy shop of building blocks that you can use to build your infrastructure without having to reinvent the wheel, without having to write your modules, write your infrastructure from scratch. It will save you a ton of time. How we use it? We use it same way we did for our regular local modules, but we choose different module source. We can point it directly to this registry, and it will obtain it and run the code. How we understand what's inside? Easy. First thing first, every module lives in its own GitHub repository, which is linked in Terraform registry on the Terraform registry page. And that's nothing but just a Terraform module. You have main TF, bunch of resources inside. Yeah, slightly more complicated than our modules, mostly because they have to take into account each corner case, each use case, each edge situation, and write proper conditional logic for every possible outcome of how this module can potentially used by thousands of users. Yeah, it has like 4K forks. Yeah. How we gonna use Terraform modules? Simple. I will remove my own VPC module and write Terraform VPC module again. But this time it will be from directly from the module registry. So, and a bunch of parameters. How we decide, how we understand which parameters should be passed to the module. Very similar to how we did with resources. On the module folder, there is input tab, which you can investigate, which you can have a look. On top of that, you can go to the module source. It will have variables.tf. Similar to what we just defined, similar how local modules use variables to communicate with outside of the world, with the outside world. Same way, public modules will accept variables in the same manner. So let's say we have name, TIDR, AZs, availability zones. We'll use our data source. Private subnets, public subnets. And we'll enable NAT gateway. Let's format everything. We will run Terraform. We will create a branch, by the way. Let's run Terraform init. And let's Terraform apply. And by the way, you don't have to go to GitHub or to module directory on the web browser every time when you want to check which variable is required. Quick life hack. You can go to Terraform. You can go to this .terraform folder. There will be modules, and the copy of this module will be downloaded downloaded to your local machine. That's why we put .terraform into gitignore. We don't want to pull all this chain of dependencies. Modules can depend on other modules and so on. We don't want to pull this chain of dependencies to us, to our Git repositories. Yeah, there are some error, reasonably. We replaced our module and we need to change outputs as well. It says VPC is object. The object has no attribute VPC seeder. Same here. We should go check our outputs. Let's find something that looks like VPC CIDR. Probably this one. Looks true. VPC CIDR block. And let's adjust our outputs accordingly. Let's try once again. Okay, at least we don't have any more the error about VPC CIDR. Let's repeat same for the rest of the attributes. It should be private. I already remember that. But in your case, you should, just as we did first time, you should go here and find proper property over here. Private subnets, public subnets. Terraform apply. So it took us less than 5 minutes to rewrite entire VPC into a simpler configuration, and everything is done for us there already. We just purchased a brand new car from a dealership and hit the gas pedal. No need to care about suspension, engine, brakes, and so on. It is very extremely useful and effective way of doing things. But you might ask, why we just haven't started out day one from this? Why we spent 20 days just to go to this situation where we deleted half of our code that we've written, we struggled with, we took care about this code just if it is for our lovely child, and now we're removing it. That's because if you want to be competent and high level world-class engineer, you should not only move like abstractions, high-level abstractions back and forth and get lost whenever something goes off. You must be able to go inside the code. And that's the reason why I showed you this GitHub repository and this modules folder. You should be able to dive into this code deeper and should be capable of, yeah, of course it will take time. Like you will not immediately read all this wall of text and understand what's happening. But at least you already have some practice and some general understanding of how it's supposed to be read. Sanjeev, your question, yeah? Do a lot of people not write from scratch, just make use of existing stuff? Yeah, that's true. If there is configurations complex than several lines of code, if it's more complex than security group and an instance in it, if it is commonly used block like VPC, right? Everyone use VPC. Yeah, and then yeah, people tend to reuse open source Terraform modules. Okie dokie, let's check. Yeah, we have our VPC created. And in the meantime, I was talking and talking. Maybe you have more questions, guys, before we move forward. Vyacheslav, yes?
So in a real work environment, it's a normal practice to download modules from the public repositories, or the companies, they usually have like their own private repositories of already, like they already have the modules built inside.
You can build your own private module registry. You can clone this public repository and fork it into your private GitHub and connect not to Terraform registry, but your GitHub repository that contains this module. So that's I would say best practice in terms of security. But in some cases, people just download directly from module registry. There is nothing too extremely bad with this approach.
Okay, thank you.
Cool. Then let's roll up the sleeves and repeat the rest of the configuration for the remaining parts of our infrastructure. Where do we start? Probably, yeah, let's do auto-scaling first. So there will be a module for the private security group. We'll give it some parameters like name, description, and VPC ID. Extract our VPC from the data source. And yeah, it's a little tricky, but to grasp it better, you can always go to the module documentation and verify its outputs, inputs, and also when you go to GitHub, there are examples as well over here. So you can see how this module can be used. Yeah, this one. So it will create VPC because it is not possible to run security group without a VPC. And for example, this one allows 443 to the range 10.10/16. And again, as I have mentioned, it has slightly different naming simply because how modules were written by their maintainers. But again, if we go and dive into the module source, it will be the same AWS security group resource that we used to have, that we used to deal with. So there will be this fancy computed ingress with source security group ID. We'll add a separate security group for external communication for our load balancer. And also egress. Egress is simpler, looks kind of similar to what we have. We have port range, head port range, protocol description, and destination CADR. Okay, data source, we have this, and let's create the auto scaling module. Auto scaling source will be. So how do I find this? I typed auto scaling group Terraform module. And there we have it. And also like even examples that we can steal. But anyways, I'll reuse my previous nodes. So I provide module source and just parameters. No need to care about launch configurations, launch templates or whatnot. Just dump our required parameters. And again, parameters can be taken. That's, by the way, usually full list of parameters. And then you go to inputs and see exactly what is allowed, what means what. We'll have min size, max size, and desired capacity. A bunch of other parameters. Including subnet ID, for example. And we'll later create an elastic load balancer using open source module as well. Couple of system things related to launch templates. Imported ones, like, for example, ID of our image. Instance type, key name. We don't need key name. Security groups, and so on. Yeah, I have removed user data. Let's recreate it. And also a couple of parameters related to instance profile. Whether we want to create an instance profile, how should we call this role, which text should we add, and most importantly, which policies should we add. Cool. Similar we'll do for our load balancer. We'll first create Route 53 data source zone. We'll create a certificate just using several lines with our module. Very easy. no need for complex validation resources and these crazy loops, just several lines. We will create one more security group, this time external, that will be assigned to our load balancer. We will create a load balancer itself. Separate module. Again, couple of parameters, name, type application, in which VPC it lives, whether it's external or external, public subnets, security group for our load balancer, target group that listens to HTTP on port 80, an HTTPS listener that listens on 443, accepts connections on 443, users and uses our ACM certificate that we've created using previous module. And as well as DNS record. We're giving it zone ID and the set of our records in a dictionary format. And RDS. Removing this. Creating separate security group for RDS. Allows communication with private. The rest is standard, but how it's meant to be used in our modules. And then another module for RDS. Environment code, size of our disk, type of instance, MySQL as a database. Same password extracted. Yeah, we keep these data extracted from our data source, and the rest of database level parameters. Let's try this out. It does not like name prefix of our ELB. Let's check what's wrong. Okay, let's then dive. It's a perfect case where we can dive into code of Terraform module, where we can dive into the code that was written by someone else. So it's dot Terraform modules ELB main.tf, and it's already saying us even which line has an error, line 69. What is that? It is okay. AWS target group main. So it says it will find and it will take this variable target groups. It will count how many target groups we provided, and for example 0, 1, 2, and extract the field called name prefix. And let's see what we have in our module inputs. Target groups, name prefix. So basically, it does not like that this value that we provided, it was then pushed into here, is longer than 6 letters. And it was probably finance, if I'm not mistaken, right? Arlanda. So let 1, 2, 3, 4, 5. Letters. Let's try once again. And this seems to be working. Yay. Yeah. Sanjeev, you have a question?
Yeah, hey Vladimir. Is that like a validation, 6-character validation, like a Terraform resource side validation, or is it should be flexible, right? Or if somebody wrote a module to enforce that?
No, it's API. So if someone wrote a module, we will see this in the module code where it is. Where we are over here, main line 69. We could have seen this in the module code, but we've read this code and we see that we just have this plain var,
Right.
with this iterator of count index, right? This means there will be list of target groups, right? And the field called name prefix from the dictionary, basically what it will be. It will be target groups equals list of objects. There will be name prefix that we specified Orlando, 7 chars, right? And let's say we will have 2, and second will be Boston, right? So that's exactly what we're passing over here. You see same sequence of brackets. Square brackets means it's a list. In Terraform, list means similar objects, and object means key value pair. And inside we have this name prefix, which was Orlando. We changed it to Boston, and it started to work. It's API, I would say. If we were to have Terraform validation, that's also, and let's make sure there is no Terraform validation. 1 second. Variable. No, there is no validation on Terraform part. That's provider API return this error.
But we didn't use this code earlier without using the modules. We were able to create the target group, right, for the auto scaling group resource ourselves. So there we didn't pass this attribute. So it's kind of an optional attribute.
Okay. Let me tell you this. I have answer to this question. And I'll even go to GitHub to make sure that my assumption is 100% correct and validated. So in auto-scaling group module, we've been using ASG, main TF. Oh, interesting. Hold on a second. No, that's not ASG. That's load balancer, main. This was target group, right? In the code, yes, it was AWS LB target group. We were using name, and it's different from name prefix, and you can see this.
So that's an optional argument, right? So if you had commented that out, it would have even worked, is it, without reducing the length?
No, it could have worked without us having to change the actual value if instead of name prefix here, we could have specified name like this here.
Oh, okay. Okay, thanks.
So, and as I mentioned, Terraform public Terraform modules are written to be as universal as possible. If your modules that you write supposed to be machete that can do only one thing but do this well and reliable, open source Terraform modules are like a Swiss knife. It has screwdriver, it has hammer in it, it has everything, like millions of different options, because thousands of end users are relying on these modules, and thousands of end users are unique and have different cases. I would say different edge cases. Some of them might want to have name. Some of them might want to have name prefix. And this construction is written in a way so that it can either accept name, otherwise it will be null if this property is not found, or name prefix. I'd say either one. They are required, but at least one should be specified, either name or name prefix. And we just need to do several things. We wait, sit staring at each other for 15 more minutes while RDS instance is created. Maybe we will be lucky if we have questions. After this is done, we will commit. We will make sure that application is still working, that there is no regression in our code. Then commit, create merge request, run Terraform destroy, and that's all.